All right, hi, welcome back. We're going to go ahead and just get started with this and get everything configured. And the first thing that we need to do is we need to go up and think about two concepts for our block types. And I'm going to kind of start with the network here, and then we're going to go into the appliance, or go to domains and then appliances. The concept of the block types is allow us to define, here's perhaps a private network and all of its child blocks and subnets, and here's a public network and all of its public, private or public networks and blocks. So at a very minimum, what I like to do is I like to set up a private and public. Tell it that it's going to be a private, that there's no parent, it is the parent of the blocks. We're going to go ahead and select these here. I won't go through all of these in particular size, but one feature of IPControl is to control the various drop-downs and the various CIDR block sizes, prefixes provided to the administrators. And you can control by root block and child block how these are defined. And then the last thing is we're going to alternate this structure a little bit. So I'm going to deselect these blocks. I don't want to really do anything with the containers at this point. I just want to add the blocks. So we're going to add private. Let's repeat this for public. Okay, and then I'm going to, at a very minimum too, do private dash data, which I'm going to then tell it is a child. Well, actually, let's do private dash region, which is a child of parent, child of private, and we're gonna kind of control this again hierarchy here manually, and then I'm going to do one more region, which is going to be say private data. And we're going to tell it that it's a child of private region. Okay. And that should give us some basic hierarchy here. So the way that I'll structure my networks is I'll have a container that will have a private 10, 192, 168, etc. At another container level, I'll aggregate it or summarize and say that in this perhaps region or data center, of this 10, I'm going to allocate a 16. That 16 then can be broken out into a private data, which we can then add additional private data, wireless, other types of things, management, and so forth, VoIP. Other types of functional use to help you kind of navigate that system. And then for public blocks, what we typically look at is if you're doing, say, split DNS, or if you're doing external public management, separating your public space from your private. This might be a way of tracking that information and tagging it. But in the ultimate concept of this is we want to isolate, internal, external. That's really the goal of all of this here. Now, aside from that, then I want to do one more thing, and here we're going to go to the domain types. And if I can find that, here it is. A little blind this morning. So now the very first type that we have is called default. And I'm going to change this again to give us some representation of, here's an internal domain hierarchy, which is basically a root, separate root for all internal DNS space. And then I'm going to do an external, which we're going to manage our external DNS at some point when we get to the DNSSEC signing appliances, and those will be tagged with external types. Okay, so what this does then is it creates also effectively views and the ability to use views for different namespaces. But we're going to effectively delegate those to administrators. And we're going to go ahead and set up our initial DNS domain, which we call it eval.com. And we are going to manage and delegate this zone. And what these mean are, if we manage it, we have an SOA. The SOA then tells us what the serial number and the refresh values are. If we do not manage it, we're only delegating it, meaning we're going to set it up as a forward zone, most likely, or point it elsewhere. We don't have an SOA, but we stub it or pull in values further. And if we don't delegate it, then you have, again, no SOA, but we do delegate this in this term. This is also to make sure that this domain appears in the various drop-downs so that we can select it as a domain for the resource records. Now, the type that we just created is internal in this regard, but you have that option to select, and I won't go through all the derivatives so we can quickly go through this and set up our initial settings here. Okay, so now I have eval, and you'll see here that it created the com in hierarchy, and now we have eval-dom.com, so the hierarchy really is that structure. And one last thing I'm going to do over here and in the container maintenance before we move forward is I'm going to go ahead and plan for these containers, and I'm going to go ahead and do, let's do Southeast, which is where I am in. And we're going to go to the block types, and the allow block types basically says at this level what type of block will be dropped in the dropdown and what can be created. Now, because we're going to create this as a regional or summarized block level, we're going to do just private region. Valid device types we'll leave as is, but this is why I mentioned having these defined earlier. We are not going to create a root block at this point, but actually we should. So I'm going to maybe modify this a minute when I come back to this. We're going to allow it to have private space allocation. So when we go to allocate a block, it's going to look for the parent in a container above it. And this is what this represents. If it doesn't have it local, it goes to its parent space. And we need to enable public here as well. In the rest of this here, once we get into user-defined fields and we get down into some of the details, we're going to come back and fill these in. So I'm going to go ahead and just do this here, but I'm going to do one more level. Also note that if you add containers, you need to click the refresh underneath the search button here. That'll then expose it here. So yeah, this we then want to have, I want to inject something here. And I want to call this organization A. And I'm going to do 1 just for sorting purposes. And then we're going to do any block type, we're going to do just private and public. We're going to do allow block type here, allow public, private. We're not going to do anything here because it doesn't need to go above itself, and we're going to leave that as is. Now, what I'm also going to do here and show you too is now to reparent these containers, you can just go here and say, here's the new place I want to reparent it. Now, there are some values here for DHCP and user-defined fields, which we have nothing, so we're going to go ahead and assume that, and that'll then move it hierarchically beneath these two. So now I have a structure to say, this is my organization, here's Southeast, and then I want to go ahead and add where I'm going to have my site and our subnets here. And I'm going to say I'm in Atlanta just for this purpose. Our valid block types, then, we're going to tell it that we're going to use private data. And this is where we might have functionally at the subnet level what type of subnets. We typically do not want private root allocation down at this level, but if you have a private egress going to a service provider and you own that space at that level, of course enable or disallow it. From the allow from parent, we only want this to go look into the regional space. We don't want it to go any further, and that'll limit us to the allocation to us for the ranges. Okay? And now we're going to go ahead and model this out a little bit. So the first thing I want to do is I want to go ahead and create my network space, and we need to have the subnet specifically for these different appliances that we're going to create. So in my 1010 space, I need to have the root block first, which I'm going to go ahead and create as a 10/8. So we do the 10 space, we're going to do private, v4, and then /8. Now we might just say, this is our root block for private space. We want to add that. I can also tell it to create the reverse DNS domain and tell it that it's going to be the internal domain type, which I will do. Now I'll come back to overlapping space, but because we're doing this at a layer beneath IPControl in this hierarchy, it will allow us to create another container similar to this organization A and allow the overlap. So if you're acquiring a new org, that might be org B, and you could then overlap these blocks for that support. And we're not doing this in the cloud, but if you had a cloud ID and a cloud type, you could tag it this, of course, for here. And I'm just going to go ahead and submit this. That creates our root block. Now, the next thing I want to do is I want to just quickly summarize this and say what the range is I'm using. So I'm going to do private region. I'm going to do 16. And I'm going to start with 10.10.0.0 because that's the network range that I'm using. And this will be what we call an aggregate range. This will become the new network for our following subnet and subnets. All right. And then lastly, I'm going to go up here and create the subnet that I'm going to be using here. And that then has the drop down for the data. Here's 24 as the size. We're going to leave 10.10, but I'm going to actually enter it manually here. the very first time you see this, you won't see very many blocks. When you first split this, it's going to start allocating, and you'll see /18s, /19s, and it readjusts automatically. So just be cognizant of that. This current status is in use deploy. That to us is a subnet. If you wanted to reserve this for future use, you would come back and reserve it. And then we can do some other things here like create the reverse or not. But then we can do other things like allocation templates and other things which I'm going to come back to. Now, just because it's good practice, go ahead and set your gateway that you have defined, and we're just going to have the DNS domain, which we set up for that purpose. Okay, and we can go ahead and do the reverse zone here too, because I should have already created that at this level. All right, so we're good to begin, and I'm going to go ahead and start with the appliances. Appliance definition. And the first thing we need to do is we need to register basically the Lab 16, the new appliances, just for the DNS and just for the DHCP. The IPControl executive and the cloud automation do not need to have their appliances or agents registered. So we are going to initially set up the 16-eval-agent1-eval-dom.com. The management IP address is 10.10.0.3. It is a virtual cloud. It is going to serve DNS, which is going to be this version, 9.18. The server IP address, we're going to use the same IP, but effectively you have 4 interfaces that can be configured. We're going to use 1 in this case. Very important next step, DHCP v4. If you're going to use the ISE appliance as is natively, you need to select and change to Diamond IP Sapphire 4.4. And then its IP address will be registered as well, and we'll save that. We'll then go in and we'll do the same, and we're going to do Agent 2. We're going to give this its IP, and this one is going to be 4. This is a virtual, this is DNS, and again, Diamond IP Sapphire DHCP 4.4. Save. Those are the only 2 appliances we need registered at this point. We will come back about the cloud automation. I'll show you where we register the endpoints. But now next step, just to understand this, when you create that Sapphire DNS and select those checkboxes, it predefines these IP servers for us based on a standard server template. So as we look at the server templates, there's a list, and one of these is going to be the standard for the Diamond IP 918. So it creates all of those servers based on that, DNS and DHCP. Now, the very next step we need to do is we need to go to the subnet and define its IP address before we can create the DHCP config or do anything really with the IPs. You can do a search up here to take you quickly to this, and just click on the link to take you to the IP, and we're going to go ahead and do our IP assignments. So in the address type, select static, and then you can do device type server, and then we're going to go ahead and give it, I'm just maybe copy this, do agent, what do we have our name? Eval, agent 1. You do not need the domain on the host name. The domain is selected from the dropdown, which we set as the default domain. So that default domain setting controls this dropdown. Any additional domains added are appended to this list as available dropdowns. From an administrator perspective, you can allow them to search, or you can disable this search and control all domains from this point here. And we're going to say that this is our Lab Sapphire VNet. Okay, now this has the ability to create the DNS records, which we are. I'm not going to do a task right now because I don't have a DNS for this domain yet. I will in a few moments. But this is how we could tell it to do a dynamic DNS immediately. Now, I'm not going to go through all of these yet. We're going to come back to this. But initially, I just want to go ahead and create these definitions. And we'll do the same here. Static, server, agent 2. And we will have that as well. I'm going to go ahead and just define my router here, just because I have it. Actually, I'm not. I'll tell you, when that gets discovered, that's going to pull it in. But I do have my server, and this is my exec. Okay. And we might as well go ahead and do our CAA while we're at it here. All right, so two things now. We have under management, DHCP, we have our server. So if we go take a look at server 1, which is agent 1, and we're going to call this our primary. When we look at the default definition, we need to make sure the very first deployment, this must read Diamond IP Sapphire DHCP 4.4, or it will modify and not understand the server type. The agent's already predefined whenever you create a Sapphire appliance. There's an agent already defined on it. If you were to install our software to control an agent on Windows or Linux, you would define an agent, give it a name and an IP, and that would then be in this list. We can further set up utilizations, which I'm not going to concern myself with at this point. And as we go out and collect leases, we do it on a task process, which you can tell it globally. You can go out and collect all the servers at a particular time and run this. Now, we do have already predefined for our appliances the start-stop scripts that we use, and we jail everything in a process. And we do have the capability of putting a custom script in line that you can tell it to run before it deploys. We're not going to at this point. We're just going to go through the configuration again. So here we'll do config again, and we're not going to, well, I guess we will. We're going to do last in as the type of dynamic DNS. There is some pre-built policies which we're going to come back to and set. We're just going to leave it at that for now. We can go in and set up our failover, and we're just going to, at this point, accept defaults for this purpose as well. And we'll go ahead and click Submit. Here, this should have set up the failover peer for this configuration. And on that failover, we would do the same process. So at a minimum, the server needs a DHCP 4.4 policy. And I'm going to go show you what that looks like here now. So we have that particular policy. And then under the management, policy sets under the DHCP column. Sorry, Cisco folks, but since I'm not going to have this in my particular video today, I'm going to remove them only to make it simpler in the interface. I'm going to keep my Microsoft and the rest, and I'm just going to remove this. No offense to those who are doing this, but I want to be able to quickly get to this. This is a standard ISC DHCP 4.4. So we want to take a look at the policies, and here we're going to set up a couple defaults. So this allows us to have an abandoned lease time, so that if an IP is pinged, it abandons it. How often or frequently will it go back and check is what this does. Authoritative must be defined at the server level. This will tell you where these policies are applicable. So if you say try to put one at a IP or address pool level, it'll fail. It'll give you a notification that it does not. The others that we want to set here are default lease time. For this lab purpose, I want to be able to manipulate things a little quicker, so I'm going to do 600. But note here that ISC does not use option 51. We use default lease time. We also use the maximum lease time, which we'll set to the same, 600. So default 6 max min. And then there's a minimum lease time we're also going to do for those devices that support this, which are relatively rare. There are other settings we can go through. One lease per client, I recommend we'll go ahead and do now. The ping check, we do want to have enabled, and ping timeout, we should have at least for 1 second. And then the rest of this information, there's one last, and that is update optimization, we want to set to false. So we want every time a lease renews for it to update its DHCP information. Now, if I go back and take a look at this, just for screen captures if you want, this will give you what this policy set looks like for this server and for this type of server. I'm going to go ahead and submit. One thing I'm going to do here too, on this toolbar, and this should be consistent across all screens, and you may have to do this multiple times. There's one that says select columns to show. Deselect the fixed header table, and these columns now will expand to enable you to see the full column space. It makes it much easier to read. You'll now see here that we have a policy. Both servers have the same policy, and here are the two assignments. Okay, so we're good. And now we want to go ahead and do a little bit of networking so that we can add some networks. So I'm going to do a couple things here. I'm going to go ahead and do add new subnet, which is basically add a child block. We have actually a different one here. We're going to do private data again, and you'll see here how it has started to carve up our network based on being utilized the first subnet. So it split that in half and then expanded it out as to the biggest blocks possible. Let's go ahead and take the next contiguous just to be frugal in our IP address space. And let's go ahead and set some policies. So first we're going to go up to here and we'll say that this is 10.10.1.1 is our gateway. Here is our primary DHCP, and then we must not have set our failover, so we'll come back and set that here in a second. If we want to go in and set other policies for lease times and others, we can. We'll come back to this as well. But we should have some type of policies, and I'm going to go ahead and select just subnet specific for this point. We're going to select the defaults here. So subnet mask, you'll see that I'm selecting Sabin subnet defaults. So the router will pick up the gateway subnet mask by how we subnetted it. The DNS domain name servers, I can manually type in a list, or I'll inherit that as well. The DNS domain and 44. So when you go to those timers, you can do that. And we're just going to set these values here, but note that you could do other custom options as well. And we're going to select our defaults. So eval.com, our DNS servers. We can add these, and this is what the option will be. So those two servers. And we can even set our reverse domain for the reverse setup here. If we're doing shared network network links, we would actually create a network link, and each subnet that's part of that secondary and primary interface, we would add those here to this link. All right, so I'm going to go ahead and submit this just to save it. And one thing I want to check before I continue is that DHCP failover setting. Okay, that's our failover, Sapphire 10.10.04. Yep, okay. All right, I'm going to have to discover that. So this is unscripted. Okay, there it is. So this is all unscripted. So you're seeing what I see, by the way. And I'm going to leave these in here because you may run across the same scenario. So apparently, exiting out of that subnet again and coming back in, or editing that, enabled that agent and updated it accordingly. So that's what we want to see here. I'm going to save this. Now, there are a number of ways I could have gotten a range, but I want to simplify this so we can at least get it deployed and have something to show. And in this video, and then we'll go on through the other configs. Here, I'm going to go ahead and I'm going to create add and then an address pool. A pool is a DHCP range to us. We can tell it to do manual, and I'm going to do from the end actually, and tell it to do 50 addresses and tell it to generate it. And I'm going to tell it to do dynamic DHCP. Now these I want to leave the same as subnet because these are inheriting these values. If I needed to point this to a different server, I could change or modify these accordingly. And when we get into client classes and some of those more advanced configuration features, you can allow and deny classes of devices through the client class configuration that we'll go through at that time. But what we want here is we just want a scope. Now, if you don't have a primary DHCP set at the subnet level, it would give you an error that there's no server, and you would effectively need to have one under this policy and setting. Okay. Now, one more thing before we push this, I'm going to go show this under the policy sets. I want to create a different policy set, and let's do 300-second lease. Okay. And I want to change the type, again, Diamond IP Sapphire, as we're moving through this. So this is a new policy that I then want to show on my server. So I want to half that 16 for this particular subnet, or 600-second, and I want to use a new policy set. Okay. I won't go through the other policies, but this should be sufficient for everything we need. And we're going to go ahead and we're going to deploy the DHCP configuration. And I'm going to go ahead and say to the primary, here's the config, stop on errors. We want to tell it to ignore DNS because we don't have the DNS fully configured yet for the server, and this may fail even. We'll find out. But I can do a hold for preview too, which I'll do too, and I'll show you this. And this will do a comparison for the last known good config. So when this deploys and is successful, it copies that, stores it in the configuration so we know how to manage it. Once the task is deployed, it goes through a queued state, sets up the target agent, and then what we should effectively see is it go into status, and then here it's in preview state. So you'll see here, this is the message I meant. This is the warning it's going to give us, and we're going to ignore that. But here I can look at the text and the config. You're going to see how we define and structure the various configurations. And here is why I want to say this is so important. The subnet definition for the DHCP server must exist for ISC to deploy. And if it does not, it will error out and tell you there's no subnet definition. This is why we had to create the subnet. Once we create the subnet and the IP address of the same name of the server, it then finds that IP, looks up its subnet, and then creates this. So it's very, very important that we use this and create it this way. All right. So we're going to go ahead and just deploy it and see if everything else in those DNS warnings will just, pass by and we'll be fine. Couple notes too, while we were doing all the setup and everything else, all of your different configurations should be set up and NTP should be working and everything should be in sync, or we're going to get failure. Now, because I told this to hold for the server config, it finished the primary, but now I've got to go in and take a look at this failover config and accept it and tell it to go ahead and deploy. We know what that's going to look like. Now, once these two are up and running, and they're going to establish the synchronization, and they'll, come up and establish that they're ready and communicate to each other. And from this point forward, any kind of leases or communication, etc., will be synchronized in real time between the two servers. And that's it. That's our DHCP server. And if we were to go out and look at that server, then we would see the services running. We can look at the logs and do some few other things. Now let's go ahead and just do, I'll tell you what, I'm going to stop right here. That's too long of a video. I may even cut this down into pieces. Then I'm going to come back and do the DNS configuration, and I'm going to go through what we call the Galaxy settings and show you some of the advanced features of our tool. Apologize for the very long length, but this is sometimes what it takes, and I'll see you in the next video. Take care.